How should cost-benefit analyses treat intangible benefits? Market forces work effectively to set the economic value of many goods or services. For example, the price of toasters or car washes tend to fall within a narrow range in any location. What is an appropriate price for more unique goods or services? This video segment examines methods to assess aesthetic and cultural values. The subsequent segment examines methods to assess human welfare and risk avoidance. Beauty may be in the eye of the beholder, yet we routinely appraise goods or services based on aesthetic and cultural values. Every purchase of high-heeled shoes is a victory for aesthetics and culture over function. Hotels often charge more for rooms with an ocean view than those that overlook a highway. This price differential may disappear if the ocean view contains hundreds of wind turbines. Sotheby's and other auction houses regularly arrange the sale of fine art. Unique goods or services, which were once declared priceless, may just turn out to be pricey. Still, cost-benefit analysis for the large-scale projects to mitigate climate change may require assessment of goods or services for which market data is unavailable. On what basis did someone select a few archaeological sites for relocation out of the thousands flooded by the three gorgeous dams in China? What circumstances would justify the construction of new dams on the Colorado River in the Grand Canyon or the Merced River in Yosemite Valley? Analysts and planners estimate the value of non-marketed goods or services based on revealed preferences techniques. Revealed preference techniques associate a non-market good or service with the actual markets for a complementary good or service. Because complementary markets depend on the use of a good or service, revealed preference techniques evaluate non-use characteristics such as historical or cultural significance, reputation, diversity, uniqueness, existence, or bequest value of saving something for future generations. Methods to gauge revealed preferences include analyses of travel costs, avertive abatement costs, and hedonic prices. Travel cost analyses estimate the monetary value of recreational or educational sites. Surveys of visitors to a site obtain information about travel distance, travel cost per distance, travel time, value of time spent traveling, and demographic factors such as age, income, gender, and educational levels. Analysts or planners calculate the number of visits to the site from people living in various locations, average travel costs per visit from various locations, and number of visits per capita from various locations as a function of average travel costs and other demographic factors. From this relationship, analysts or planners predict how the number of visits from a given location will vary with rising costs such as higher entrance fees or higher gasoline prices. The sum of visitors from all locations as a function of rising costs produces a demand curve. Demand curves usually take a concave shape where inexpensive costs encourage a high number of visits and vice versa. Area under the demand curve provides an estimate for the recreational or educational value of a site. For example, the annual recreational value of Yosemite National Park is around $450 million, and the Great Barrier Reef in Australia is between $700 million and $1.6 billion.